What is additive manufacturing? Additive manufacturing is a revolutionary technology that has transformed the way products are designed and manufactured. Also known as 3D printing, additive manufacturing is a process of creating three-dimensional objects by adding layers of material on top of each other. This technology has disrupted traditional manufacturing methods by enabling the production of complex geometries and customized designs with ease. Additive manufacturing has found applications in various industries, including aerospace, automotive, healthcare, and consumer goods. How additive manufacturing works. Additive manufacturing, also known as 3D printing, is a process of creating three-dimensional objects by adding layers of material on top of each other. The process starts with a digital design file that is sent to the printer. The printer then reads the file and begins to create the object layer by layer. The first step in the process is to create a virtual model of the object using computer-aided design (CAD) software. This software allows designers to create complex shapes and structures that would be difficult or impossible to make using traditional manufacturing methods. Once the design is complete, it is saved as a digital file and sent to the 3D printer. The printer uses this file to create the object by adding layers of material one at a time. The material used can vary depending on the printer and the application, but common materials include plastics, metals, and ceramics. The printer works by melting or softening the material and then depositing it onto a build platform. The platform is lowered after each layer is added, allowing the printer to build the object from the bottom up. Once the object is complete, it is removed from the printer and any support structures are removed. Overall, additive manufacturing offers a unique way to create complex objects quickly and efficiently. While there are limitations to the process, such as the size of the object that can be printed and the cost of the equipment, it has revolutionized the manufacturing industry and opened up new possibilities for designers and engineers alike. Applications of additive manufacturing. Additive manufacturing, also known as 3D printing, has revolutionized the manufacturing industry by enabling the production of complex and customized parts with ease. This technology has found applications in various industries, including aerospace, automotive, healthcare, and consumer goods. In the aerospace industry, additive manufacturing is used to produce lightweight and high-strength components for aircraft and spacecraft. The ability to create complex geometries and reduce material waste makes it an attractive option for producing parts that are difficult or impossible to manufacture using traditional methods. In the automotive industry, additive manufacturing is used to produce prototypes, tooling, and end-use parts. It allows for faster design iterations and customization of parts, leading to reduced development time and costs. In the healthcare industry, additive manufacturing is used to produce patient-specific implants, prosthetics, and surgical tools. This technology enables the creation of highly customized and precise medical devices that can improve patient outcomes. Additive manufacturing is also used in the production of consumer goods such as jewelry, toys, and home decor. It allows for the creation of unique and personalized products that would be difficult to produce using traditional manufacturing methods. Overall, additive manufacturing has a wide range of applications and is continuously expanding into new industries. Its ability to produce complex and customized parts with ease makes it an attractive option for manufacturers looking to improve their production processes. Advantages and limitations of additive manufacturing. Additive manufacturing, also known as 3D printing, has gained popularity in recent years due to its numerous advantages. One of the biggest advantages is the ability to create complex geometries that would be impossible with traditional manufacturing methods. This allows for greater design freedom and innovation. Another advantage is the ability to produce small batches or even one-off parts economically. This is particularly useful in fields such as aerospace, medical, and automotive industries where customized parts are required. Additive manufacturing also reduces waste by only using the exact amount of material needed to create the part. This not only saves on material costs but also reduces the environmental impact of manufacturing. However, there are also limitations to additive manufacturing. One limitation is the size of the parts that can be produced. Most 3D printers have a limited build volume, which restricts the size of the parts that can be printed. Another limitation is the materials that can be used. While the range of materials available for 3D printing is growing, it is still limited compared to traditional manufacturing methods. This means that some parts may not be able to be produced using additive manufacturing. Finally, the speed of production is another limitation. While 3D printing is faster than traditional manufacturing methods for small batches, it is still slower for large-scale production runs. Overall, additive manufacturing offers many advantages over traditional manufacturing methods, but it is important to understand its limitations before deciding if it is the right choice for a particular application.